Hello everybody, today I want to solve again a rather simple yet engaging problem from Savchenko Problems in Physics. This problem points out a few very important ideas that you must pay attention to when solving problems using Newton's laws and when solving problems about rotating systems in particular. So let's get into the problem. A horizontal disk begins to spin around its axis with a linearly increasing angular velocity, omega equal to epsilon t in time. At what angular velocity will a body located at a distance r from the disk axis begin to slide off if the coefficient of friction between them is equal to mu? Well, we must first think about the accelerations in this system. First things first, that is a rotating system. So obviously there is some centripetal acceleration. Okay, that's okay, we know how to find it. It's rather simple. We're given both the angular velocity and the distance from the axis of the disk, so that's rather simple. But what about another part of our acceleration? In fact, there is also a tangential acceleration. Since we're given that the angular velocity also changes, the tangential acceleration appears. So let's write it down. There is a picture of the accelerations in the system for a body located at a distance r from the axis of the disk. And using Pythagorean theorem, we can find the total acceleration. There is its formula. Then we think about another thing that we're given in the problem. And now we think about the question. At what angular velocity will a body located at a distance r from the axis of the disk start to slide off if the coefficient of friction between them is mu? Well, it's rather obvious that we must think about the friction force here, and static friction in particular. Then we can write the Newton's second law as ma being equal to the maximum force of static friction. So basically it's ma being equal to mu mg. Therefore, it's rather simple to write this thing down because we know both A and mu, and then we get this. From this equality, we find the final answer for omega. When looking at this equation, we must think about one thing. It only works if epsilon is smaller or equal to mu g divided by r. But what about the situation in which epsilon is bigger than that? Well, at this case, the tangential acceleration will be so large that the static friction force will just instantly transition into the sliding friction, and therefore this case corresponds to the answer of omega being equal to 0. So overall, we get the answer to the problem. That is it. Thank you so much for watching. I really appreciate your likes. So if you want me to solve some other problems, not necessarily from this book, please let me know in the comment section below. Thank you.